Graphing quadratic equations. Quadratic equations are of the form y equals ax squared plus bx plus c, where a, b, and c are constants, and a does not equal 0. This is the standard form for quadratic equations. We also have what we call vertex form, but for now we're just talking about standard, the regular standard form. Some facts about quadratic functions. Y equals ax squared plus bx plus c, right? Highest degree or order is 2. That's the exponent on the x. It's an x squared, so it's our degree. Graph is a U-shape called parabola that opens either up or down. It contains an axis of symmetry. Vertex is the lowest or highest point on a graph. And the y-intercept is in the form of 0, c. It has up to 2 x-intercepts in the form of g, 0 and h, 0. So once again, it could have 2 intercepts, 1 intercept, or no intercepts depending on the case. So notice I've blinked out on the left side, on the right side here already. Agreed? That way hopefully makes it easier to see. But let's remember that our zeros, where are our zeros located? Y-intercept, your x is always 0. X-intercepts, your y values are always 0. So be careful with those. So let's do a quick sketch over here to make it easier to visualize in our blinked area. And first, parabola sketch, rough sketch for us. In this case, we can see the x-intercept there on the left side, and there's another x-intercept on the right side. So this example shows 2 x-intercepts. And likewise, we can see a line of symmetry or axis of symmetry. There it is. Essentially, it's where everything starts to repeat for the y values, in other words. So from the left side and the right side, if you were to be able to fold this into a half, you'd see that they meet up exactly the same. They are repeated y values. Not necessarily x, though. Okay. Keep in mind, in this case, x-intercept happens to be there at the bottom, which happens to be the vertex. So this is another example for us. And likewise, we have the y-intercept. There it is. And we have an axis of symmetry. Do notice, for both of these cases, your vertex are the lowest point. So it'll be somewhat similar for both cases at the very bottom. But how about if we have something that's upside down, something like this? And let's remember, in this case, we had 1 x-intercept for this particular case, the blue line. So the green line. There we go. There is our vertex, and it's the highest point for this case. So if your parabola is U-shaped, you have a low point, your vertex is the lowest point. If your parabola is upside down, an upside down U or an N, sometimes we say it, it's the top that is your vertex. So there is our axis of symmetry. And let's realize that for that green line or green graph, there is no x-intercept. So no intercepts for that case. So going from left to right, we have the red graph, shows 2 intercepts, blue graph, 1 intercept, it barely touches the x-axis, so that counts as an intercept. And then the green graph, no intercept on it. They all have a y-intercept, except we can only see on our graph one of them, because the other 2, it will be outside of our graph area. So, hence the reason why we can't see it in this case. Let's try graphing an equation. So, is y equals x squared a quadratic equation? And what does it look like? Well, first of all, let's try just some random examples. Similar to what you would do for a linear equation, right? You just pick random values. May not be the best choice in this case scenario, but we'll try that. We pick -2, -1, 0, 1, and 2. And we may get lucky and get something that's useful. And we're going to graph it in a bit. So labeling our x and y axis will make it easier. and our general formula for quadratic equations, y equals ax squared plus bx plus c. So in this case, it's just y equals x squared. Is that a quadratic equation? Well, it has the x squared, right? Let's find out though, if it is or not. So let's plug in the values that we selected. The first value that we selected, -2. So y equals -2 squared. So that implies -2 times -2, right? Because it's squared, it repeats twice. So -2 times -2, that will give us 4. So I highly recommend that whenever you're working on your homework, you show at least one calculation like we did here. The rest you're welcome to fill in from your calculator. But for this case, since we're starting to learn to graph them, we'll do all of them, or the ones we selected at least. Let's go in for the next one, y equals -1 squared. That's the other value we selected for x. -1, so -1 times -1. Negative times negative is positive, 1 times 1, still 1. There we go. Y equals the next value of x we picked was 0. 0 squared, 0 times 0, it's still 0, right? So y equals 0. And of course, y equals 1. We picked the 1 for x. So 1 squared. 1 times 1 is 1. So, hey, look at that. Seems to be repeating, right? Y equals 2 squared. 2 times 2, agreed. 2 times 2, 4. Hey, once again, look at that. Let's fill in our tables. 4, 1, 0, 1, and 4. There we go. We filled it into our tables. The values, we can now graph them on our graph area. Okay, so now that we filled them in, we can try sketching them. There's our first coordinate or point that we draw, -2, 4. Next one, -1, 1, 0, 0, 1, 1, and 2, 4. It's basically looking at our tables, agreed? They're coordinates. So there we go. Does that look like a parabola? It sort of does, right? How about if we trace them? Trace over the dots and do a rough estimate. Your estimate should be roughly like mine, roughly. Notice it's kind of wobbly here and there, but it still works. That's an approximation. So, is it a quadratic equation? Is now the question. Let's realize we have an axis of symmetry. In this case, it's the y-axis. It's where our y values repeat on the left side and the right side of it. And we can actually see it via our calculations as well. We also can notice there's a vertex. There's a vertex, low point. The vertex in this case is located at 0, 0. And for this case, it also happens to be the single y-intercept that we normally have, and in this case, a single x-intercept. So it crosses or touches the x-axis at 0, 0 also. So our vertex happens to be all 3 points. The vertex, the intercept for the y's, and the intercept for the axis. So, is it a quadratic equation then? Yes, it's a quadratic equation, and it's a parabola, essentially. So, there is our answers for this particular case. And our sample graphing. So let's check our calculator, just for reference. So going into our calculators, turn it on, and go to y equals. So y equals will bring you to this menu. And we want to enter x squared. So x, you can either use the caret key and then put a 2, or you can also use it as x and then the square button on the middle of your calculator there on the left side would also do it. So we'll go to zoom and do a zoom standard, option number 6. And there we go, we can see our graph. It looks sort of like what we have there, right? Probably can do a quick overlay. And we can kind of sort of see the arrows up at the top. Alright, but in this case, what we're looking for is to be able to fill in the table later on. Press the second button, the graph, at the top right button, second, and then graph, should now give you a table. And from here, you can fill in your table. So if we notice, we select the -2 would give us 4, and then -1 would give us 1, 0 gives us 0, and then 1 gives us 1, and then once again, 2 gives us 4. Recommendation next time. I highly recommend you come in, plug your equation in here. In this case, it's x squared. You graph it so that you can see it, what it looks like, and from there, select your x values. And then help yourself by seeing the table. Let's use the table typically to make it easier. But do remember, you want to show at least one calculation. At least one calculation. The practice makes the bigger difference. Agreed?